Good afternoon, guys. It's your boy. And today we're going to be doing scatter plots and lines of fit 4.4.
Perfect. Thank you, Will.
Yeah, no problem.
All right. So, scatter plot. Does anybody know what that is? What a scatter plot is?
It's like a bunch of lines. Isn't it like a bunch of lines?
Yeah, it's a bunch of what? Points. Yeah, it's a bunch of points. Okay. So, a scatter plot is generally used to show some kind of connection between two things. So let's say you were taking a class in statistics. In statistics, they try to find connections between things. So maybe you were looking at like how long somebody drives and I don't know, the likelihood of getting into an accident. So they might look at what's the trend. Is there a connection between if somebody drives like 6, 7, 8, 9, 10, 11 hours straight, are they more likely to get into an accident? Yeah. So a scatter plot is basically a way to look at a picture of data. Because our brains work better when we see a picture. A lot of times a picture is easier for us to understand. So the data sets, okay, in a scatter plot are graphed as an ordered pair. Another example might be, let's say X is how many hours you study, and Y is the grade you get on the test. So maybe there's a connection between how long you study and the grade you get on the test. Okay? How could we tell? We could make a picture and see if the picture looks like there's a pattern.
So guys, on your notes, it says A, then scatter plot's in bold. You want to fill in the blank on your notes with scatter plot. Then you have lines with 2 dashes. On that first line, you want to write the data sets are graphed as ordered pairs, X, Y. Then on the next line with the dash, you want to put scatter plots are used to show trends.
Yeah, it says shows.
Shows, I know. Should be show.
Yes.
Grammar.
I think he's a man. Point out a mistake.
Okay, so I'm going to show you guys a picture of a scatter plot. And just by looking at it quickly, I want you to tell me if you think there's a pattern or there's no pattern. There's no trend. Okay?
Oh, there is no trend. That is random.
Scroll down so you can see the bottom part.
It's on our paper too.
It's on your paper too? Okay.
Yeah.
I showed her the page as well.
Can we not anymore?
So this is a scatter plot that's showing two things. It's showing how much sugar is in grams is in a smoothie, and then how many calories. So does it look like those dots are
Scattered?
totally random, or does it look like there's kind of a pattern to them?
They're random.
There's a pattern.
Where's the pattern?
There's a dot, and then there's three dots, and there's a dot, and then there's 3 dots.
But there's 4.
Not so much that, guys. They kind of look like they're kind of in the all kind of like in the same area. Think about, guys. Think about the warm up, right? Not the first line, not the basic arithmetic, but the second part we did. What did we ask you guys to do
I don't know
in that second part of the warm up? What do you think, Savannah? What are you gonna say?
what. Oh
What
no,
are you
it's
gonna
just
say?
something about the graph.
What do you want to say? Go ahead.
Oh, well, it's kind of a trend. Because like nothing decreases, it just goes up.
Okay.
Yeah,
That's a good point.
exactly. As you head to the right, it keeps heading up in general. There's kind of one point over here that looks a little different, but I would say the rest of them kind of look like they would lie along a...
Let me say, if you let this kind of circle, yeah.
Exactly. You could almost kind of draw in your own line and kind of see that a lot of those points, with maybe the exception of one of them, they pretty much are pretty close to that line. Okay, they're not super random. They kind of lie along the line. That's what we're looking for. That's called a trend. Sometimes the line might go up, sometimes it might go down.
Yes, the pattern, what we mean by that is to kind of look for all the dots to kind of be, like Ms. Hager said, either kind of being all in the same area going up, or kind of being all in the same area going down. like you said, you might have one that's kind of like that one that's on 290. It might be a little bit off, but the majority of them are kind of in a pattern.
And what you want to be able to do is describe that pattern to someone. So if you asked me to describe this, I would say that from this data, it looks like the more sugar you put in the smoothie, the more calories it's going to have. That's how you would describe the pattern. The more sugar you put in, the more calories are in the smoothie. That's what I would say.
Letter C is like, the question is like cut off.
Letter C? Okay, I'll make sure you can see it if you need to copy part of it down.
Alright.
We got it up here. Thank you. Okay, so let's look at this picture and let's see if we can answer some questions about it. So it says the scatter plot shows the amounts of sugar, that's the x-axis, and the amount of calories. If you put in that much sugar, that's the y-axis. Now, they draw these little symbols here. Does anybody know what that thing means that I just circled?
Oh, does it look like it has an well, so when you I can't think today.
You see them like when people before they die in the hospital.
Yes.
On a pulse.
Like a break or something?
Exactly, it's a break. Look at what the x-axis is going by. 46 plus 4 is 50. Plus 4 is 54. Okay, it's going by 4s. But look at this. It doesn't go from 0 to 46 by 4. It skipped a bunch of numbers. Okay, so whenever you draw a scatter plot, if you want to skip a bunch of numbers, you need to put in one of those little symbols. That means it's a break.
You guys notice, how is this, like this graph, how is it different from the graphs we've kind of worked with so far this year? Okay, so the numbers are high, so I agree with what Joe said, the numbers are higher than what we usually deal with. What do you think, Josiah?
There's no the plus sign in the middle.
Okay, so it doesn't like make an X, right? Okay, what were you gonna say, Savannah?
Well, I mean, it's kind of labeled.
Okay, it's labeled, we have the axis as a label, okay, I agree with that. Yeah, like, we're only getting that, like if we looked at like the graph we gave you guys on the warm-up, we're only looking at, because all the numbers are positive, so like this is like a snapshot of like that upper right-hand corner. So everything, all the graphs we deal with this week, right, this is called the scatter plot. It's just gonna be that one little positive quadrant of numbers.
And someone said something really important about labels. You have to put labels. You've got to tell whoever's looking at this graph, what is the x-axis? Is it sugar? Is it money? Is it time? Whatever it is. Okay? Same with the y-axis. And you have a title on the whole thing.
Is it chewy bars?
So, Joe, how many calories in 56 grams of sugar? How could you use that graph to figure it out?
So you go like, well, on the x-axis where the numbers are, and then you try to find where 56 would be.
Okay, let's try to find 56.
It'd be the
And the way I'm going to do it is I'm just going to make a line to kind of give me a guide.
yeah.
It'd be right about there.
Yeah, and then you
So
follow
it's
it up to
270.
Yeah.
Well, because there's
Well, just
55
nice.
and 56 and 56.
Thank you, Joe.
So you put a line where you just try to see where 56 is. Look at that dot.
20 and 70.
And then trace over to the left 270 calories. So how many calories are in a smoothie that has 56 grams of sugar?
270.
27.
About 270. Okay, next question.
And again, guys, as Mr. Hager said, pay attention to how the scatter plot is numbered. Like this one, again, we had the break. Down at the bottom it was going by 4s, and on the y-axis it was going by like 10s. So we have to be able to sometimes estimate where a number's going to be.
Like, so Will, can you tell me how many grams of sugar in 320 calories? Tell me how to figure it out.
Well, calories, it's on the y-axis.
Okay, calories is on the y-axis,
And then
yeah.
grams is on the x.
All right, so what do I do?
Well, you look for 320. and
Okay.
go all the way to the right.
All right,
So
320,
Yep.
go all the way to the right, yep.
And then 70.
And then, yeah, go down, and you can see It's right at 70. So how many grams? 70 grams. Okay, so part C, if you need to copy that down, because
It's cut off.
I'm gonna make a compliment. As long as you guys put the if you want to copy the rest of it down, you can, but if you have the answer down, that's okay too.
So this is more of a sentence you have to describe. What is happening to the number of calories in the smoothie as you add more sugar? What happens to the number of calories as you continue to add more sugar? Okay, look at the pattern. Savannah?
The number of calories increases.
Exactly. That's exactly what you should put. The number of calories increases. In general, okay, there's a little bit of an exception to that. Like if you add more sugar, it looks like there's a few of them that stayed the same. Even though they added more sugar, somehow they kept the calories the same. But in general, okay, that's what scatter plots are. They're general patterns. Okay,
You call it like an estimate mistake?
yeah, look at the big picture. Okay. Okay, any questions on part C? So this trend that you're seeing, that's one type of trend. This trend heads up. Okay, I think, yeah, we're going to mention that right now. So correlation. Okay, I think you got a spot on your notes. Write that in.
Guys, if you want to just like, guys, in between the graph of the smoothies and that, where all the three graphs on the bottom, you can just put correlation if you want. You can write it in.
Okay, so a correlation.
You don't have to write the whole thing, just write correlation. Now guys, on the top, you see lines on the top of each of those graphs with all the dots on them. You're going to have to write in what each one is.
Okay, so a correlation it's just a relationship between two sets of data. So I might say that there's a correlation between how many minutes you study and the grade you get on the test. There's a correlation. And there's different types. We're going to go over the 3 types right now.
So guys, think back, right, to part 2 of the warm-up and what we had you do. In part 2 of the warm-up, right, we had you find slope and do a few other things, all right? So based on what you know about graphs and things like that, what do you think the correlation is for the first one, the one all the way to the left? Look where all the lines are going. They're going up to the right, right? Up to the right. So what kind of a correlation would that be? Think about slope. Mallory? Positive. Yeah, it's the same, it's pretty much the same exact idea what we talk about when we do slope, right? If they all go up to the right, all the numbers are increasing, it's going to be a positive correlation.
Does everyone understand what that says on the bottom? As x increases, that means as x goes to the right, y goes up. As x increases, y increases.
So just like Savannah told us in the last one, right? As the grams of sugar increased, the number of calories increased. That was a positive correlation.
How about the second one? As x increases, y decreases. What kind of correlation do you think that is? That's a negative. Now, the last one, there isn't really a correlation. So,
So 0.
No solution.
Correlation.
we just say there's no correlation. Yeah.
Yeah, but no.
Yeah, they're kind of all over the place, there's no correlation. Hey guys, on a test or homework or something, if we ask you to identify the different types of correlation, we'll give you, it won't be a multiple choice, but we'll put in the directions what we're looking for, positive, negative, or no correlation.
So maybe an example of no correlation, like let's say I somehow assign numbers to where you sit, and I look at where somebody sits in class and the grade they get on the test. Maybe there's not much of a connection if you sit in the left or the right side. It doesn't matter the grade you get on the test. There's no connection. Okay. Or maybe there would be, which would be interesting to see.
Yeah, like.
Maybe if you sit in the front, do you get higher grades than if you sit in the back? I don't know.
Well, Savannah's higher lectures can put like paper on it.
So the connection that Mr. Roy made in the warm-up, they mentioned that in your book. Okay? Think of a positive correlation just like you would a positive slope. it goes up to the right. Negative correlation, think of it like a negative slope. It goes down. All right, so before I even show you the picture, what do you think? Do you think there would be a connection between how old you are and how many vehicles you've owned throughout your life?
Yeah.
What do you think it would be?
My stepdad's on 23 cars.
Like the older you are, the more cars.
Yeah, the older you are, you've probably bought more cars throughout your life.
Probably like 60 cars.
So that's what I would have thought, right? I would have thought as you get older, you've bought more cars. But when you look at a set of data, you can't go in with an assumption that just because it makes sense to you, or maybe you think that it should be true, don't let that bias the problem. Looking at the data, does it look like there's a correlation?
No.
No. I would have thought there would have been. If you asked me, I would have said, yeah, I think as you get older, maybe you've bought more cars. But here's somebody who's 55, they've only owned 3 cars in their life. And then somebody who's, 35 or 30 has already owned 5 cars. So, in this case, no correlation. Okay, so don't go with what you think is true. Look at the picture. Okay? Let's look at the next one. Temperature and coat sales. What do you think? Do you think as the temperature changes, do you think something would happen with the amount of coats stores sell?
Yes.
I would think so too. As it gets colder, what do you think would happen?
More plastic.
Probably selling more coats. Okay? As it gets warmer, they sell less coats. Let's look and see what the data says. Average daily temperature. As the temperature increases, what does it look like is happening to the number of coats?
Decreases.
It decreases. What kind of correlation is that?
I mean, yeah.
That's a negative correlation.
The higher the temperature, the less, the fewer number of coats you gotta sell.
Okay, is it perfect? No. But, I mean, you could draw a line pretty much right through the middle, and I would say that the pattern follows that line in red. Okay, so that's a negative correlation. Stopping distance of an automobile and probably how fast it's going. That's probably what they're going to look at here.
Yeah.
Is that it?
It's miles per hour on the bottom.
So what do you think? Do you think there's a connection between how fast you drive and how long it takes to stop?
Yes.
Yeah, that one I would definitely say. The faster you go, what?
The more resistance it is to your stop.
Or slower you'll stop. Well.
So in terms of how the stopping distance, if you go faster, it's going to take more distance to
There's
stop.
kind of like bigger bigger stuff like 18 wheels and stuff that the bigger they are, the slower you'll stop. Well, the farther you'll stop.
Yeah. So yeah, you'd have to take into account how big of the vehicle and stuff. But assuming you're comparing 2 cars of the same weight, okay, the faster you go, the longer it takes to stop. So what kind of connection is that? What kind of correlation? What do you think? Positive, negative, or no?
Positive.
Positive, yep. Positive correlation.
Grandpa.
Okay, any questions on that?
Which one is that?
Grandpa.
Wait, what were the first 2?
First 2, no correlation, and I think it was, what was the second one? Negative? Negative. Okay, so let's do this one together, and then maybe Mr. Roy, you can jump in after the next one. All right. This one says, tell whether the data shows a positive, negative, or no correlation. Okay, look at that table quickly. Look, you have 2 more seconds. 1, 2.
I got a question.
That was the point.
Yeah, I
Oh, they already have it.
Yeah.
Now, if you look at that table quick, can you tell
No.
the correlation? No. Our brains, they do better with pictures, right? So if we draw that as a picture, and you give somebody 2 seconds to look at it like this, like if we go back to this one, 1, 2. Yep, I can tell you real quick, it's negative. Real quick, positive. So what we're going to do is turn this into a picture. Okay, and see if we can see it.
It doesn't have to be in order.
Now, no, they can give you the data in any order they want.
Okay.
Now, when I set up a scatter plot, what did I say you have to make sure you do? So somebody looks at it, knows what it is. Yep,
Label it.
you gotta label it. 3 labels, x-axis, y-axis, and then a title. What's the x-axis in this problem?
Age of car years.
Age of a car in years. So let's label it age. You could just put years, just like that. Good enough. Age in years. What about the y-axis? Savannah?
The value.
That's the value. Right, you got to tell the person it's in thousands. So that doesn't mean if the car is 1 year old, it's worth $24. That's 24,000. Okay? If the car is 4 years old, that's 18,000. Okay? So value in thousands. Okay. And now, what would be a good title for this?
Age of car years.
Age of car years? Well,
So,
what's the scatter plot going to show you?
so,
Prices of cars through
So-
years.
Yeah, the price of the car over time. That's a good one, through the years, yep. Were you going to say that, Savannah?
I was gonna say like, no, I can't think of it.
Well, Joe got it. Joe has a good title. The price or the value of a car
Yeah, I
over
was
time.
gonna say-
Cars going from 0 to
I couldn't think of
100.
it.
Oh my gosh.
Well, is this about speed, Will? You said cars that can go from 0 to 100? Are you thinking like miles per hour?
Yeah.
So this graph isn't really showing us how fast a car can go. It's just showing us what a car is worth.
Cars over time.
That might be a good connection, though. Is there a connection between the value of a car and how fast it can go?
Yes.
Yeah.
Maybe.
Cars over time.
Depends, maybe.
Okay.
Cars over time.
So value of car.
It's not $18.
That's
18,000.
Oh.
All right. Now I have to decide on some
Yeah,
labels.
so guys, when you get to this part, make sure you pay attention make sure you pay attention in terms of the numbers that you're given, right? And how big your graph is. In a lot of cases, you're not gonna be able to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The numbers are gonna be bigger. So you gotta do a little planning before you set up or before you write on your graph.
Okay, let's start with the X's.
Oh.
Do I have enough room on the X's left to right to go by ones?
Yeah.
Yeah, I can go by ones. You could start with 0, you could start with 1. That doesn't really matter. So we'll start with 0. 1, 2, 3, 4, 5, 6, 7, 8.
Wait.
Just enough. Now, if I go by ones on the y-axis, I'm going to have 0, 1, 2, 3, 4, 5, 6, 7, 8. Is that good enough?
You can go by 7
Or no,
by 3s.
You go by 5.
I went by 3.
You want to buy 3s? Yeah. Don't go by something that's huge. Like I wouldn't go by like 50s, because if you go by 50s, you're gonna have everything smushed between 0 and 50. You're not even gonna be able to tell.
And if you went by 5s, guys, you wouldn't really fill up that whole side.
So 9, 12, 15, 18. Do I have to go bigger? Yeah.
Yeah.
19. I gotta go one more. That's perfect. You've used almost as much of the graph as you can.
So you want the 24 on top.
Oh, 24. Yep. We need one more.
So I was like,
So again, guys, you've got to pay attention to how you want to label. I mean, obviously labeling your axis, like what it is, value of cars, age. You're gonna see that in the problem. That's pretty simple. But in terms of how you want to number each axis, that might take a little bit more. You're gonna have to plan that a little bit more before you actually do it.
Now, this thing that I just circled, that's like a what? It's got an x and a y value.
Oh, fraction.
Not a fraction.
It's a
We
graph.
did it in the warm-up.
It'll be
Oh,
It's a point.
coordinate.
It's a coordinate. So now graph the coordinate 1, 24,000. So go 1, 24. Put a dot. Okay. Nathan, what's my next coordinate?
You go right 2 and up 20 to 21.
2, 21. Now, if you only have 2 dots, you can't tell there's a pattern. You got to have more than 2, like 6 or 7. Then you can really see.
You guys, the way that those coordinates might look on a different graph, they may look different. But because the way that we labeled it, and the way we numbered each axis, that's why it's the way it is.
Okay, some coordinates, as you're going through, you're going to have to just estimate, like 19. I just put it a little higher than 18. Some of them are right on it, like 5, 15, 6, 12. It's going to be right on it. 7, 8. Well, just put 8 a little bit below 9. Okay, put it like right there. And then 8 up 7. So now, if you look at that graph real quick, you should be able to look at that for less than 2 seconds and be able to say if there's a pattern. Yes or no?
Yeah.
Yes. What do we call a pattern? What's the fancy word?
That's with a C.
Correlation.
Correlation.
Oh,
And what type of correlation?
negative.
Negative. So there's a negative correlation. So what does that mean? Can somebody tell me specifically what does it mean to have a negative correlation on a value of car over time scatter plot? What does a negative correlation mean? Savannah?
It means when the age of the car increases, the value increases. Yeah.
Exactly.
Good.
The older that a car gets, basically, the less it's worth. It's exactly what she just said. That's the pattern.
Yeah, it depends on, you know, that it kind of depends on what kind of car it is.
Yeah.
Like you buy a really rare car and you keep it in good condition, like whatever, like a 1950, I don't know,
There's this guy.
hot rod or something, yeah. Over time, if you keep it in mint condition, it's gonna be worth more money because it's very rare. There's not many of them anymore. But if you have a car like my truck is like a Nissan Frontier, there's so many on the road that over time, all right, the more that it's not gonna be worth a lot of money because it's not very rare. There's so many on the road. Joe, what were you gonna say?
So there's this guy at the Chevy place, when my mom was looking for a new car, and the dealer, he was saying that this guy brought in a Firebird, great condition.
What fire? What?
Firebird,
Oh,
great condition and stuff, and he was able to trade it in for a brand new Corvette, like without paying anything.
Works.
he's probably.
Okay. So, any questions on this the scatter plot? All right. Perfect.
Easy.
All right, so now, guys, we're gonna take it like one step further. So when the data shows a positive or negative correlation, which we talked about, you can model the trend in the data using a line of fit. So remember, like Mr. kind of just drew a line. He said it kind of follows that. It kind of follows that trend, like this one. He kind of had an equal amount of dots on the top, equal amount on the bottom. All right, that's kind of like that's pretty much what we're gonna do with this part of the lesson. It's called a line of fit. All right. So on your notes, you should have a blank to write in line of fit. Again, like we said, with it, is it not written on there?
Eric says he's using a line of fit.
Okay, no big deal. then. Okay.
But do we need that?
Watch
No, it's
your
okay.
photo.
Because we have it written on there anyways, using a line of fit to model data. That's okay. All right. So 4 steps. You guys have the steps on your notes. So all you're gonna do is just fill in what they said. So step 1, like we just did, make a scatter plot of the data. Now there's a lot of I'm not sure what step 2. Okay. So there's a lot of I guess hidden information there. That's not. That's a big idea because that means you have to make sure you label both each axis. That means you have to put the numbers right in. Make sure you number each axis in a way that makes sense. Like the last one, like Savannah said, go by 3 because that's the way that was the best to model the data. Right?
Everything that
So there's a lot. Everything that we just did. All right. That's pretty much making a scatter plot. Labeling, coming up with a name for your scatter plot. All those things come under making a scatter plot. All right. Next thing, decide whether the data can be modeled by a line. So now you look at it. Okay, it looks like all the dots are kind of going down to the right. Okay, that's negative. Well, all the dots are kind of in a pattern, all going up to the right. Okay, that's positive. If they're all over the place, you can't do it. So if they're all over the place, what do we call that if the dots are all over the place?
Negative.
Scattered.
No.
Oh, no
No
correlation.
correlation, right? So if they're scattered all over the place, you can do this. If there's no correlation, you cannot do this. Right? Like it says in the notes, when the data shows a positive or negative correlation. Because if we had no correlation, there's no way we could draw a line that kind of maps the points that are there, or the dots.
Now, sometimes you have a pattern in data. I just want to go back to that car braking example for a second. And some of you might say, it looks like this is a line. I would argue that if you had more data, it would probably be a curve. I can't really tell because I don't have enough data, but it doesn't look perfectly straight to me. It looks like a curve. So this is still one we couldn't do. Okay, we have to get data that really looks like it's a straight line, not a curve. Okay, curve is a little more complicated. You might do that in like a statistics class, but we're going to stick with lines.
All right? So again, just looking at it to see, is it positive, is it negative, is there no correlation? If there's no correlation, you can't do this. There's no line of best fit if there's no correlation, because the line will be all over the place. All right? Step 3, like Mr. Hager's already done a couple times. You want to draw a line that appears to fit the data closely. All right? Again, remember with this stuff, it's an estimate. It's not going to be exact. Like, okay, I have 5 dots below it. That means I have to have 5 dots above it, or 5 points. It's not always going to work that way. If you have, maybe you might have 3 below the line and 4 or 5 above. That's okay, as long as it's kind of relatively equal. If you have like 10 below the line, 10 dots below the line, and 2 above, that's not a really good line of fit. You probably didn't draw it in the right space. All right. So again, it's all estimating. It's not always going to be perfect. All right? It's not always going to be perfect. And Mr. Hager already showed you guys a couple of times, just, again, how he did it. I mean, he didn't do it perfectly, but it was pretty close. All right, so you're going to draw that line. And then step 4, we're going to write an equation using 2 points on the line. Right? Now, the most important thing, it doesn't have, this will make more sense to you guys when we actually do it, but the points do not have to represent actual data pairs. Right? What that means is, it doesn't, when you draw your line, it doesn't have to go through a dot perfectly. And like I said, it'll make more sense to you guys when we actually do it. But they must lie on the line. But they must lie on the line of fit. Right? That probably seems a little bit confusing to you guys, but I think when you see it and when we actually do it, it'll make a little bit more sense. Right? Yeah, it doesn't mean your line has to go through perfectly like 2 points. The 2 points that are already there, your line doesn't have to go perfectly through them. If it goes through like a point where like on the graph, where like the graph makes it like little coordinate lines make it X. If your line goes through there, that might be a good coordinate to pick, because it's still going to be on that line. Again, it's probably, like I said, it's probably a little confusing right now, but when we do it, I think it'll make a little bit more sense to you guys. All right? So again, like step 1, step 2, we've already done. Last example we did, we drew a scatter plot. All right? Step 2, deciding what the correlation is, we've already done that. We know how to do it. All right? Now, step 3, step 4, step 3 is not too bad. It's just a matter of making an estimate and drawing that line. So equal amount of dots or points that are above and below. And step 4 is kind of new to us. But again, like I said, I think it'll make more sense when we actually do an example. People okay with this? I can move on? Everyone's good? Okay. There we go. Alright, so the table shows the weekly sales of a DVD in a number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. Interpret the slope and Y-intercept of the line of fit. So this is why, guys, in the warm-up, this is why we went back to graphing a line, finding slope, finding the Y-intercept, because we're coming back to it now. That's why we had you guys do it. That's why we had you guys do it in the warm-up. What equation do you think we're going to use when it says this? When it says write an equation and then interpret the slope and Y-intercept. What equation do you think we'll use, Valerie?
Y equals mx.
Y equals mx plus b. Again, I know it's not in your notes, but again, it's showing up again. Y equals mx plus b. Someone refresh my memory. I know there's two things in that equation that mean something. What's one thing? What's one letter in that equation that means something? Josiah?
Y.
Nope.
M is slope.
M is slope. I agree. Anything else? Gemini?
The B is the Y-intercept.
B is the Y-intercept. And again, we talked about this. We talked about this in the warm-up. Someone refresh my memory. Y-intercept, how do we find that again? If I was just given a graph and I was asked to find the Y-intercept, I wasn't given an equation, I was just given a line on a graph. How would I find the Y-intercept? We talked about this in the warm-up. If I was just given a graph, how would I find the Y-intercept? Just a line on a graph. How would I find the Y-intercept? We talked about this in the warm-up. How would I find the Y-intercept?
Where the line crosses the Y-axis.
Yeah, like Madison just said, look at the line, see where it crosses the Y-axis, there's your Y-intercept. Alright? How about slope? Jack, how about slope? We can do slope a couple different ways. What's one way we can do it? What's the easiest way to do it? Okay, it's gonna be a fraction, right? So what do we say? What's another term for like slope? What could we call it? Something over something.
Oh.
Rise over run. So we could say slope, one way we could do it is, like we talked about, rise over run. So what's two ways we could find it? What's two ways we could find slope? Talk about it in the warm-up. Mallory?
The y2 minus the y1.
Yeah, we could. I think for the sake of this, again, I'm going to try to squeeze it in there somewhere. Y2 minus y1 over x2 minus x1. So I think for the sake of this, guys, because we may get some bigger numbers when we do this. So this is probably the best way to do it. Figure out your y2, your y1, x2, x1, because the numbers are going to be a little bit bigger. And on that scatter plot, again, remember, the way we number each axis is not always going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it would be hard to count. It'd be really hard to do unless we had a set of information that went by ones. But usually we won't. So this is probably going to be the best way to do it. y2 minus y1, x2 minus x1. Alright? So here's all the information. When we give you the table, we're always going to tell you what the x is. We're always going to tell you what the y's are. So it's saying that after 1 week, this DVD made $19. That's really not, I don't care. After 1 week, $19, it's really not making any money. Look at the millions, right? Good, no. Good. So sometimes you have to pay attention to what it says. Just like we did the one, remember Josiah, we did the one with the car, you're like, the car's only worth $19? Remember you said that? I'm not making fun of you, I'm just showing an example. Again, so you have to pay attention. Again, if we're dealing with money, it might say millions, it might say thousands, it might say 10,000s, whatever. So in this case, after 1 week, 19 million. After 2 weeks, 15 million. It just keeps going on like that. All right? So,
Oh, it's going down my too.
so in the case of this, guys, the cool thing about this is we already gave you, sometimes we may give you the scatter plot already set up. It's labeled, right? Each axis is labeled. It's all numbered. So sometimes we may give you the scatter plot already set up. You just have to put the dots. Like the one we did before, it was the whole thing. We had to label everything, put the numbers in, do all that stuff. For this, we don't have to. All right. So what's the first thing I'm gonna graph? Savannah? Okay. So first week is week 1.
And then you guys.
I go 19. Uh-oh, 19's not
So you go.
good. It's like X just said. He recognized that it's going by 2s. It's 19, so it's going to be in between the 18 and the 20. So I'm going on 1. I'm going right in between 20 and 18. All right. Jack, what's the next one? So I just did this one. What's the next thing I got to graph? 2 and 15. So where's my weeks? Is it the x-axis or the y-axis? Okay, so 2 on the x. Then where am I going? 15. Uh-oh. There's no 15 on my y-axis.
Between 14.
Good. Good. So you guys get the point. Again, I'm making a big deal of it, but just pay attention to it. Again, even though it's not on there, just see how it's like X did on the first one. He knew it was going by 2s. He knew the number would be right in between. All right. Then we got 3, 13. Again, not a perfect, so it's going to go in between. Then we're going to have 4, 11. We're going to have 5 and 10. We're going to have 6 and 8. We're going to have 7 and 7. And we're going to have 8 and 5. So, that was that. So we made our scatter plot. We graphed everything. All right? Now, what's the next step? All those steps we wrote down. What's the next thing? Savannah?
Decide whether it could be like on a line.
All right, so does that, I forget what our second step was. Decide whether the data can be modeled by a line. Can we model that by a line, Savannah? What would you say? What kind of correlation is that?
Negative.
Negative, right? It's going down. Again, everything's relatively in the same area. All right? So, next thing was draw a line, right, Madison?
Yeah.
All right, draw a line that closely fits. Well, you okay back there?
Yeah.
Okay, man. Draw a line that closely fits. So what Mr. Hager did is he took this red line. Again, it worked out. A couple of our dots, the line goes right through. Okay, it may not happen like that every time. And again, what Noah puts as his line may not be exactly what Sydney puts for her line. But it's going to be pretty close. All right? I mean, if Mr. Hager had his line like way up here, that's no good. If he had his line way down here, not going through anything, not kind of keeping a balance in between the top and the bottom, that's not good. But again, there's going to be like something like that. That's not going to work. All the points are below the line. Here, we got a couple. Yeah, we got like 3. We got like 3 below it. 1, 2, 3 above it. We got a couple that are kind of like right on it too. All right. So again, what your line is could be a little bit different than what Connor's is. It's not always going to be exact, but as long as you're in the general vicinity, that's okay. Again, it's an estimate. It's not always going to be exact. All right. So now, what was the next step, Madison?
Write an equation using 2 points on the line.
Okay, so again, the points have to be on the line. Like it said in the notes, it doesn't have to be exact. I don't have to pick this point and this point. I don't have to. I say that you want to look for a good point. What I mean by a good point is I'll show you some examples that are on the line. I would choose that. I would choose this. I would choose this. I could choose this. I could choose this. 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 That. Any of those things. Now you probably say to yourself, well, Mr. Roy, those aren't exact points. That's okay. They're on the line. I say they're good points because the line goes like, see how this makes like a little X? Mr. Hager's gonna, you want to highlight it for Mr. Hager?
What, you go ahead, Mr. Roy.
It makes see how it makes like a little X and the line goes like right through. See how the little like coordinate lines make like an X? Where your line if your line goes through like perfectly, like each of these things that I circled, if it goes through perfectly, that's something you want to pick. Why do we want to pick that? Because it's not a fraction. It's going to be a whole number. All right. So where the line goes through the X. See how that each on the line it makes a little X. That's where you want to go through. Those are the points you want to pick. You only need to pick 2. But the big thing I want you guys to understand about this is you don't have to pick exact points that you put there. As long as the line goes through. Like if I just drew it up here. See how it goes through right here, where it makes an X, it goes through there, it goes through there, it goes through there. Those are the type of things you're trying, that's a coordinate that you would want to pick. Alright? So for slope, we just have to pick 2. We only have to pick 2. I don't care which ones we pick. I'm going to say, my suggestion would be, the lower the number is, those are probably the numbers you want to pick because they're going to be easier to work with. I mean, in this case, we got some bigger numbers, but I would choose something that's down here. So, in this case, I have an actual point that my line goes through. What is that coordinate? This one right here.
6, 8.
So it'd be 6, then it'd be up 8. So my X would be 6. I'm mistaken, do you want me to put that in millions?
You can just do 8.
Let's do 8, okay. So that's one nice coordinate I could pick. That's on my line of best fit. A line of fit, I'm sorry. Remember, a line of fit is just an estimate. Let's pick this one, for example. Right there, it goes through nice. This one right down here. Mr. Hager's going to highlight it for us.
Which one, Mr. Roy?
Right here, Mr. Hager. Yeah. All right. So, Xander with a Z. What's that coordinate?
8, 4.
8, 4, right? I'm at 8 on the X. I'm up 4. 8, 4. Now, like I told you, for this, I wouldn't count because it's going by 2s on both parts. So you can't just, it'd be a little bit more difficult to count. All right? So we talked about we want to use and then what did we say the formula was again?
X2 minus Y2.
Careful.
Y2 minus Y1.
Good.
X2 minus
Y2 minus Y. Y2 minus Y1 over X2 minus X1. Alright? So someone tell me, what's my Y, Sophia, what's my Y2? Based on how I labeled it. 4. 4 minus, because it's part of the formula. Connor, what's my Y1? What did I label Y1?
8.
8. Very good. And I got X2. Josiah, what's X2?
X2 is 8.
Good job. Remember, minus is part of my formula. And then my X1 is what? 6. Now, when I do the math, right, and I figure this out, what kind of a number should I get based on what the correlation shows us? Negative, right? It's a negative correlation, just like if I had a negative slope. When I figure out the actual number, it should be negative. If I have a negative correlation, when I figure out the number for the slope, it should be negative. Again, we just did this in our basic math, right? 4 minus 8? Negative 4. On the bottom, 8 minus 6? 2. Now, simplify this. What goes into both? Savannah?
2.
2 goes into both, right? So I can divide by 2, divide by 2. Savannah, when I do that, what do I get?
-2.
I'm just gonna get, come on, I don't even need the fraction, right? It's gonna be -2 over 1, which is
2.
-2. Alright? So what did I just find out?
B.
Slope, right? M, I'm mistaken, I just wrote it down. -2, right? Now, my B, what does B stand for again, guys?
B stands for Y-intercept.
Good job, Savannah. Alright? B stands for Y-intercept. Now, somebody told me earlier, Y-intercept is where the graph crosses the y-axis. So look at the graph, everybody. And it doesn't go all the way through, but where does it kind of look like it's going to go through? At what number?
20.
20, right? Do we all see it up here? Connor, do you see that?
Yeah.
See, it's kind of getting ready to go through 20. There's my 20. Now, this kind of goes back to what we did a few weeks ago before the midterm. I have my slope. I have my y-intercept. I figured it out. Now I just have to put it in slope-intercept form to create an equation. All right? So our mistake already started. Y equals, what should come after that? -2, right? And like Noah just said, it's going to have the x with it because it's the slope. What's the rest of it? Plus 20. -2x plus 20. That's the equation for your line of fit. All right? That's your equation for your line of fit. Again, try your best with this, guys. Pick coordinates that go through, that are nice on the graph. As you guys are packing up, we're getting a little low on time here. Make sure you guys hold that sheet I gave you for the warm-up today. Make sure you hold on to it. We'll do those questions as the warm-up for tomorrow at the end of the lesson. Like I told you guys, it's first week of third quarter. All right. Also, our last academic week before vacation. Remember, only two more days of new stuff this week. We're reviewing a new MCAS on Thursday. First test of third quarter on Friday. Yo,